abide by the Pycon APAC code of conduct and consent to being recorded and streamed. Okay, so.
Thank you so much, Mr. Luca. Good morning, everyone. Welcome to Pycon APAC 2024 for the first session today, hosted here at National Ulama University of Jakarta. My name is Angela Putri, and I will be your moderator for this session, and we are excited to have you here to delve into the latest innovations in Python. Our speaker for today is Mr. Gutaya, who will be presenting on the topic of speeding up transcribing with GPUs and CPUs. Mr. Gutaya is a machine learning engineer at Shuraida, building innovative AI. Without further ado, I'm going to give this talk to Mr. Gutaya.
Selamat siang, saya nama Yuta Yanagi. Sejak saya mendengar bahwa saya adalah member in Pycon APAC, saya telah bekerja keras untuk belajar bahasa Indonesia. Good afternoon, everyone. My name is Yuta Yanagi. Today, I would like to talk about how to speed up transcribing with GPUs and TPUs. Let me introduce myself. My name is Yuta Yanagi. I am the member of the Chura Data, and I am also the candidate of the PhD at the University of Electro Communications UEC in Tokyo. I came from Okinawa, and it is the southwest island of Japan. And my hobby is playing Japanese video games and cosplay, and this is the one of the famous Japanese games characters. It is not famous in Indonesia, but the origin of character loves to codings and little bit crazy behaviors to speeding up her ability of the learning. This is the agenda of the presentation. In the first, I introduced to the automatic speech recognition. Sometimes it is abbreviated as ASR. This is the core technology of the transcribing. In the second, I compare with the GPUs and TPU in the transcribing with several modules. In the last, I show the demonstration of the summarization on this track. Okay, so the first part is introduction. I explain why the speeding up transcribing is important. I joined the Chura Data this spring. So one of the tasks for new graduates is writing minutes of the meetings. There's a lot of the meetings, daily, weekly, and daily is a regular meeting with the teams of the members, and weekly meetings, in my company's case, the formal meeting with the customers. And we need to write the minutes accurately, especially the weekly meetings, because it contains important information which is provided by the customers. So, but it is tedious task because we need to keep attention to listening carefully, who are speaking and what they are speaking, and we are the new graduates, so we don't know a lot about the team members. So if I miss to who are speaking or what they are speaking, we need to listen again after the meetings with recorded voice. So this is a time-consuming task. Therefore, we made a system of the automatic generation of minutes of the meetings. The input of the system is a recorded meeting voice. This contains a lot of the speakers, and there's the information of the metadata, especially in the Google Meets or Zooms of the speaker's name, but sometimes there's situations of the real physical situation. And the output is the documents of the meeting minutes. It in details who said blah, 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 and who recognized blah, and so on. This is a breakdown of the system. In the first, we need to record the meetings. The recorded voice has several speakers' spoken voice. The system divides into the segments of the speakers, and we call it the speaker diarizations. So that this part output is the list of the segments, which is divided by the speakers. After that, the main part is generating the transcription of the segments. It is a big progress because big process because it requires a long time, and this is a sequential information like the text or music and voices, and it usually requires a long time because we need to input to the system step by step. After that, the language model summarized into minutes format from the transcriptions of the meetings. It doesn't take a long time, just input the transcription with prompt into the large language models like ChatGPT, Gemini, and so on. In this time, we use the Gemini because it is inexpensive to use and testing the system. This is a detailed process of the transcribing. In the first, the waveform data is converted into the acoustic features. Like it is not the main topics of the waveform transformations, but the information contains the features of the voices. After that, the acoustic models convert into the format which is available to input the language models for transcribing. After that, the language model outputs are the list of the tokens, and the tokens need to be converted into the output text as a transcribed. And let me introduce the Whisper. This is the most famous open source transcription models, which are developed by the OpenAI. The picture is the figure of the Whispers, and some of the audiences recognize that the shape is similar to the transformers. This is base of the system in the GPT or any other kind of the LLM. And the first part is log-mail spectrogram. This is part of the past features, and the acoustic models convert into the encoder blocks. And encoder blocks is one of the important parts to the inputs of the decoder blocks. The decoder blocks is transcribing with the feature of the voice and the previous tokens. So that's why it needs a long time. The input is a list of the tokens, so that is a process of the sequential data. So what's the best way to speeding up transcribing? In the Google Cloud, we can use the three kinds of the devices: CPU, GPU, and TPU. I check the best practices every device is in the same model. The latest version of Whisper Large. This is the biggest model, but it is also accurate and slow to transcribe because there are the huge models and we need to wait a lot of the calculating. And I checked in the three perspectives about time to transcribing and cost of the transcribing and usability of the transcribing. And this is a summary of the devices. In this presentation, I checked the performance of CPUs and GPUs and multiple GPUs and TPUs. I don't tell details about the CPUs, and the best practice is to use the small models to check if the system can used by the users. And if you want to apply the large model into the CPUs, the middle column is the time for 1 hour voices. Sorry, that's a typo, not 1 hour, but that's 5 seconds, sorry. That's a 5-second voice, and the CPU needs to wait 1 minute. So this is 20 longer than the original length of the voice. So I don't care about the good practice to use the large models. And the cost for 1 hour voice is $3.01 because it takes huge times and that cost will become expensive. And in the GPUs, it is easy to use, and I explain the details later parts, but it is fine to transcribe 5-second voice into 1 seconds, and it is easy to use from the managed service. In the TPUs, it is super fast, and time for 5-second voice is under 1 second. I explained the examples for the longer voice, and it is so expensive, but there are the problems of the usabilities. So in this part, I will provide the comparison of the devices. The first part is the GPU. The faster whisper is a good method to transcribe it. So this is a summary of the GPUs, and it is a realistic way of the transcription because it is easy to use to integrate. It is easy to use from the Google Cloud and as a managed service like a Cloud Run. It means it is easy to integrate with web applications or any other process of the AI, like the speaker diarization in these sessions. And because, so we can use just in time when we want to transcribe within the only the task of which is issued by the Cloud Run. In addition, there's another transcribing model which is accelerated by the other tools of that processes in and by that faster whispers. And this is the official tables which is provided in the repository. This the target model is V2, so that's the previous one, but time and maximum GPU CPU memory is smaller than the original one. So I tested the performance of the faster whisper with 1 hour voice. Before that one, this is the usage of the faster whisper. The red rectangle is a part of the transcribing voice with dividing into the segments. The segment is original context in the faster whisper. That's another one from the I said before, the previous one. But and the segment is generators of in the Python. So convert into the iterator like the list methods, and after that, obtaining the transcribed text. And I tested it in the 5-second voice. The whole process includes the making the instance of the models and transcribing is 3.83 seconds. So this is shorter than the original length. Yeah, this is part of the transcribing, and actual time of transcribing is under 1 second. So this is shorter than 1/5 of the original voice. I also tested the actual voice. This is the length of the voice is 58 minutes, and the situation is my doctoral defense Q&A sessions. So there are several speakers, and they are the professors of the universities, and there's a lot of the sharp questions or a little bit harmful question for me. So that's why I selected it as example once. And yeah, but I need to improve, so that's why I wanted to transcribe and summarize into my minutes formats. This is the result of the 58 minutes voice into the faster whisper. The actual time is 10 minutes and 3 seconds. So this is approximately 1/6 from the original length. It is so fast. But there's another way of the transcribing voice with multiple GPUs. And so in the automatic generation of the minutes, we have several voices which are divided by the speaker diarization. That's the wrap of the whole process of making minutes. So we divide it into the segments by the speaker. We call it speaker diarization. So we can apply it to the multiple threads or processing. I adopt multi-threading. So if each thread is allocated to the one GPU, so we can, in this system, we can use the GPU as a transcribing simultaneously. We need to keep in mind the efficiency of scheduling and balance of the voice length. For example, if the one of the segments has a too long time, more than decades of the minutes, the other thread needs to wait until the thread transcribing is completed. But yeah, it is one of the good way to accelerate transcribing faster. I tested the multiple GPU instances, and the detailed instance has 4 GPUs. So I made the extended the source codes in order to apply several GPUs. The upper left rectangle is new options of the making the model instances. This one explains there are a lot several GPUs, and this is a list of the GPU indexes. And bottom left rectangle shows that it took 2 minutes 1 second. This is the average of the 10 times with the shortest time in the 3 times. And so the serial processing by GPU was 10 minutes. So this is 5 times faster than the single GPU. So this is a good way to transcribe meeting voices if you use the parts of the speaker diarization. So let me explain the details of the TPU. In short, it is the fastest, but there are some issues to use it. So let me explain the details of the TPU, but we need to compare with the systems of the CPUs. In the CPUs, especially in the machine learning, the CPU needs to calculate step by step if in the image recognitions. The GIF video shows the MNIST of the predicting the within handle like within numbers. In contrast, TPU make a parallel process by a lot of the cores. It enables to use for machine learning. TPU is more effective in machine learning than the GPU. GPU is also good for not only in the machine learning, but also computer graphics. But TPU is specialized for the machine learning. This is a summary of the TPU, and the transcribing time is under 1 minute with multi-tips because there's automatic optimization systems between the cores and chips of the TPU. However, it is unavailable to use from managed service like Google Cloud Run. So it is hard to integrate to the web applications. So there are the two usage scenarios of the usages. One is the create environment on demand, but it requires the preparing and it takes a little bit long time. And keeping instance up every time is also expensive to keep the instances, especially the large instances. The TPU is empowered by the JAX, and this is the library which has compiling and functional program paradigms. In these examples, this is provided by the official repository. The red line is easy to understand, but yeah, using the functions with the automatic calculating of the graduations and GIT function is, and the VMAP function is the compiling into the GIT, which is useful from the JAX. It is hard to understand, and explaining the TPU needs requires another tracks. But fortunately, we can use the Whisper JAX. This is a rough part of the JAX, and it enables us to use the TPUs with the good points of the TPUs. And the Flux Whisper pipeline is a wrapper of the whole process of the transcribing with inputs of the voices and transcribing and decoding. So we need to use, we need to do with this project is making the instance of the pipeline and the transcribing with the pipeline functions. That's all. That's all. I tested the time of transcribing with the latest TPU. The instance had 8 chips and the time was 35.1 seconds for the 58 minutes voice. It is approximately only 1% of the original length. It is an unbelievable speed, but yeah, I tested 10 times and the calculate averages with the shortest time in the 3 times. So we're in the good situation of the using TPUs. The speed is best, but we cannot use from managed services. So therefore, when the instance is massive request and the whole length of the voice is huge. There are two types of the scenarios. It is worth to use TPUs. But in the other situations, especially in my and in our company's cases, GPUs to integrate with and use as a web application backend. This table shows the good points and weak points of the every devices. The GPU is easy to integrate to web, and especially the multi-GPU is strong for the batch processing. However, single GPU is not slow. It's not so slow, but it is slow comparing with the other ones. And multiple GPU needs to coordinate the length of the voice. So it is complicated to manage the transcribing processes. And TPU is super fast for a lot of the voices or super long voices, but it is unavailable from Cloud Run, so the situation of the TPU is a little bit limited. And this is a summary. There's no time to explain. This is elapsed time for 5-second voice, and GPU is faster than CPU. And elapsed time for 1 hour voices. The GPU with large models takes to 10 minutes, and multiple GPU was approximately 2 minutes. Middle bar graph is another one, but yeah, there's no time to explain. And the TPU is so small times. So in the last, we show the fastest way by the TPU as a demonstration. I upload this presentation voice and transcribed by TPU and summarized by the Gemini API. Okay, so actually I recorded this voice, and from now on, I share the mirroring. Yeah, this is a recorded voice, and I upload it on the Google storages. I, I wonder if it takes how many times. Okay, so okay, it's uploaded. So I prepared the Python demo. So before we waiting the transcribing, let me show the source code of the ones. It is small. This is the functions of the calling Gemini with parameters, super parameters, and this is the functions of the downloading voice from the Google storage. And this is the main part. And yeah, this is the part of the transcribing and just calling the pipeline instances. And okay, this is small. This is the server, and it downloaded, and yeah, the transcribing is started. So yeah, let me continue the ones, and after the transcribing, we make the prompt into the Gemini. So please summarize following the transcription of the text in the Pycon in English and Indonesian. The formatted elimination with 10 bullet points. Each line should be short within 20 words, and the outputs are short as a demo. And I attached the transcribed text. So after that transcribing completed, we can see how many seconds that it takes the transcribing. So just actually there's less time of the Q&A session, so I can ask 1 to 2 questions within transcribing. So do you have any questions? Go ahead. Sorry, could you say that again more loudly, please? No problem?
When do you get this one, the TPU basically? How do you run the TPU?
TPU, the resources of the running TPUs?
Yeah.
Okay, yeah. And there's documents of the TPUs in the Google Cloud. So yeah, I think that's enough to learn how to use TPU from any other kind of the modules, except JAX. There are the materials of how to use TPU as TensorFlow or PyTorch. So yeah, if you want to get the information about how to use TPUs and yeah, using that documents, official documents of the Google Cloud is the best way, I think. Okay, so time's up. So let me check the outputs. It takes 44 seconds, and this is the English summary. And yeah, the content is don't have any problems, and I don't know a lot about the Indonesian summary, but yeah, I hope it is helpful to the audience who is not strong good for the listening English. So yeah, that's all. It's time's up. So asking another question or any okay. That's it. Yeah, so that it's time's up. So if you have questions, I stay in the sponsored booth as this costume. So yeah, I think it is easy to find.
Thank you again, Mr. Yuta, for your again in the next session. Thank you, everyone. And once again, a round of applause for Mr. Gisela.
Terima kasih. Thank you.
The slides, right? The slides you mentioned the CPU like cloud.
Cloud? Google Cloud? Yeah, this is the cloud TPU's documentation. Yeah. And you can select the Indonesian. And some of the documents are written still in English.